Okay, let's talk about something really fundamental to being human. We argue
All the time. Yeah.
constantly, whether it's just a friendly debate about, I don't know, the best pizza toppings or trying to get a group to agree on plans or, navigating those really complex political discussions.
It's often messy, right,
Yeah.
and emotional. It's rarely just about cold, hard facts.
Exactly. Context, values, who's talking to whom, all that stuff plays a massive role.
Absolutely. It's this incredibly complex, sort of multi-layered process. And for centuries, thinkers have tried to understand how we do it, what makes an argument work or fail.
Right. It feels almost intuitive to us, but when you try to actually break it down,
Yeah.
it's tough. So imagine trying to teach a computer to do that.
Yeah, that's a huge leap.
To not just process language, but to understand, evaluate, and maybe even generate arguments. That's the really fascinating and challenging field of computational argumentation.
And to help us unpack this, we're diving into a recent paper that just came out online, February 2025, in the journal Autonomous Agents and Multi-Agent Systems.
The paper's titled An Introduction to Computational Argumentation Research from a Human Argumentation Perspective. And that's the hook, really. It uses the way we argue, how humans do it, as a kind of map to understand what researchers are doing with computers.
It gives a fantastic overview. So our mission in this deep dive is pretty much to navigate that map with you, highlight the key areas of research, some of the surprising difficulties, and maybe why tackling this challenge is so important for the future of AI. AI that can truly reason and interact with us.
Okay, so where does the paper start this journey? It starts by looking at us, right? Humans.
It reminds us that understanding argumentation, well, it has a long history. You've got Aristotle, Tolman, thinkers who tried to formalize this very human activity.
Right, trying to pin it down.
Exactly. And the paper specifically draws on a framework from informal logic, I think it's called the Canadian approach, that breaks down the human argumentation process into 4 distinct phases.
Okay, what are those?
Well, first you have to identify that an argument is even happening.
Spotted in the wild, basically.
Yeah. Then you analyze it. What are the pieces? What supports what? Then you evaluate it. How strong is it? Is it sound? Is it logical? And finally, you might invent a response or, build your own argument.
Identify, analyze, evaluate, invent.
Okay. That makes intuitive sense for what goes on in our heads. And the paper uses these 4 phases as the organizing principle for the whole computational field.
Precisely. It structures the research into tasks that sort of mirror these human abilities. It's actually a really elegant way to see how the AI world is trying to, catch up to this fundamental human skill.
Which leads us right to the paper's core contribution, framing computational argumentation around 3 main interconnected tasks. What's the first big piece of that puzzle?
The first task they talk about is argument mining. Think of it as the AI trying to listen in or read text and figure out where the arguments are hiding.
Argument mining. So like digging through data, looking for the premises and conclusions and stuff. Essentially, it's the automated extraction of arguments from natural language sources.
Oh.
I mean, everything from news articles and social media posts to legal documents, transcripts of debates, you name it.
And mapping that back to those human phases you mentioned, argument mining seems to cover the first 2, right? Identification and analysis.
Yes, that's right. Spotting the argument and then figuring out its internal structure.
So how does it work? Is there like a standard process?
Yeah, the paper describes it often involves a kind of pipeline. First, you need to segment the text into meaningful units. Just splitting by sentence isn't always enough because context is so vital. The paper mentions these argumentative discourse units, or ADUs.
ADUs. Okay. So chunks of text that actually contain argumentative content.
Right. Finding the chunks that matter for the argument. Then, within those units, you need to detect the components. Like, what's a premise here? What's the claim? What counts as evidence?
Oh, interesting. Can it tell different types of evidence apart?
Well, that's the goal. The paper notes researchers are training systems to spot different kinds, statistical data, maybe personal testimony, analogies, things like that.
So the system has to learn that, like studies show, or in my experience, often signal a premise or evidence.
Exactly. And these techniques are being applied in, pretty diverse areas. You can imagine AI helping analyze thousands of online product reviews, summarizing the arguments for and against, or sifting through legal documents.
Or even in checking claims.
Yeah, or even automatically checking factual claims made in public speeches. Now, it's important to note this is about computationally identifying that a checkable claim has been made, not judging the truth of the claim itself. That's a different problem.
Got it. Just flagging the argumentative move. Okay, and the third part of this mining pipeline.
That's identifying the relationships between these components and units.
Yeah.
Does this sentence support that claim? Does this argument attack that one? And this is where understanding context and needing background knowledge becomes really, really challenging for machines.
Yeah, I can see that. I remember the paper pointing out that a big hurdle here is just the sheer variety of data, right?
Mm.
How arguments are expressed. People argue so differently depending on the topic, the platform.
Definitely. That heterogeneity makes building general systems pretty tricky. And like a lot of AI research that relies on big text data sets, there's a bias towards English data, which is obviously a limitation if you want global applications.
What about the tech behind it?
The paper also notes the field heavily uses neural network models. LSTMs, GCNs, transformers, those advanced AI techniques that are good at pattern recognition in language. And there's a push towards end-to-end systems that try to do the whole mining job in one go, from raw text to structured argument.
And where do large language models, the LLMs we hear so much about, fit into argument mining?
Well, the paper is, I'd say, cautious but optimistic. LLMs are clearly powerful at handling language, right? So researchers are definitely exploring using them for tasks like extracting really complex argument structures, or maybe even generating examples to help train other systems.
But there's a catch.
Yeah, the paper highlights a key challenge. LLMs are fundamentally trained to predict the next word based on patterns they've seen. They don't inherently reason or follow logic in the same way that these argumentation frameworks are designed to do.
Oh, okay. So they can sound convincing, maybe even identify linguistic patterns related to arguments, but they don't necessarily understand the logical force behind them. Is that it?
Precisely. Their outputs can sometimes be inconsistent or hard to interpret, especially when that logical structure is really critical. The paper seems to suggest that combining the linguistic power of LLMs with the explicit reasoning models from computational argumentation, that's likely where the future lies.
Hybrid approaches.
Exactly. Could be stronger than either one alone.
That makes a lot of sense. Okay, so we've mined the arguments, we've identified the pieces and the relationships. What's the next major task the paper outlines?
The second big task is argument-based knowledge representation and reasoning, or KRR. This is all about taking those arguments we've mined and representing them in a structured way that a computer can actually process, evaluate, and, well, reason with.
Okay, so this feels like the core thinking part of computational argumentation. Mapping back to the human phases, this covers analysis and evaluation.
Exactly. How do you turn the messy reality of human arguments into something a computer can manipulate logically? The paper talks about two main approaches to represent arguments computationally.
Okay, let's hear about those.
So first, there are abstract representations. This is simpler in a way. You basically treat arguments as abstract nodes in a network. You don't look at the internal content of the argument at all, just the relationships between arguments, and usually it focuses just on attack relations.
Like a diagram where one box points to another saying attacks, just the high-level conflict?
Yes, pretty much just a graph of who attacks whom. Dung's abstract argumentation framework is the foundational model here. The paper gives a simple example. Argument A1 attacks A2, A2 attacks A1, A3 attacks A2, A4 attacks A3. It just captures that structure of conflict, nothing more.
Okay, that definitely simplifies things. What's the other representation approach then?
That's structured representations. This is where you actually dive inside the arguments. You represent their internal logic, the premises supporting a claim, and the logical connections between the arguments themselves. This is where you try to capture more of the nuance of how humans reason.
Right, so this is where you might include things like the values someone holds, or different types of connections, not just attacks.
Yes, exactly.
Yeah.
The paper mentions examples like frameworks that incorporate values. So if one argument promotes, say, social good, and another promotes economic growth, the system can potentially factor in a preference for one value over the other when it's evaluating the arguments.
That's getting closer to how people weigh things up.
It is. And it also highlights frameworks that explicitly model support relationships, not just attacks. Because, humans don't just tear down arguments. We spend a lot of time building them up with supporting reasons, too.
Right. We gather evidence, we reinforce our claims. It feels much more complete to include support, doesn't it?
It definitely captures more of the richness of human debate. So once you have these representations, whether abstract or structured, you get to the stage called argumentation solving. This is the evaluation part, using defined rules, they call them semantics, to figure out which arguments in the network are acceptable or justified, given all the relationships.
So based on who attacks whom, and maybe who supports whom, and maybe values, the system decides which arguments win out in the end.
Precisely. It determines the status of each argument accepted, rejected, maybe undecided. Now, the paper makes a really crucial point here. While these formal models are elegant and logically sound, they don't always perfectly match how humans actually reason.
Okay, why is that? What do the models miss about our messy human thinking?
Well, humans deal with implicit information constantly, right? Unstated premises we just assume our audience understands. They call those end themes.
Yeah, we don't spell everything out.
Exactly.
Yeah.
And we also use phenomena like accrual. That's where several individually weak reasons, when put together, actually make a strong case. Think of, like, listing 5 small reasons why you should go on a trip. None are decisive alone, but together they feel pretty compelling.
Oh, I get that. Formal systems might struggle with that if they just evaluate each weak reason in isolation.
They might, yeah. And human judgment about what makes an argument acceptable can be influenced by context, emotion, even just how the argument is phrased. The paper mentions studies showing that even basic logical ideas, like one argument defending another by defeating its attacker, aren't always applied consistently by people in practice.
Huh. So there's this fascinating gap between the clean logic of the computational models and the messy intuitive reality of human debate. Bridging that gap seems like a huge challenge.
It really is. It's a significant area of current research trying to make these formal models better, reflect actual human cognitive processes, not just idealized logic.
All right, so we've found the arguments with mining. We've represented and evaluated them computationally with KRR. The third task is where the rubber really meets the road, isn't it? Human-computer interaction using arguments.
Yes, argument-based HCI. This is where the AI system actually interacts with a human using arguments, and it connects most directly to that human phase of invention. Generating arguments and engaging in dialogue.
Okay, so this is the part where the computer tries to, argue with us? Or persuade us?
Potentially both. Key areas here include argument generation, basically.
Yeah.
Training computers to create natural language arguments from their internal structured representations.
That sounds incredibly hard.
It is. Generating arguments that are not only logical, but also coherent, relevant, and actually sound natural is a major hurdle, especially doing it consistently across different topics and domains.
I imagine systems like IBM's Project Debater are trying to tackle exactly this, building arguments on the fly.
They are, yeah. That's a prime example, aiming for that kind of sophisticated argument generation in a real-time debate setting.
Yeah.
But making it truly flexible and domain independent, that's still a significant challenge. And then there's the flip side, computational persuasion.
Right, getting the computer to be convincing, that sounds potentially very powerful and maybe a lot concerning.
It's definitely a complex area and raises important questions. How can an AI system select or even tailor arguments to be persuasive to a specific human? The paper really emphasizes that persuasiveness isn't just about logic.
No, it's subjective, right?
Totally subjective. It depends heavily on human factors like personality, values, prior beliefs, even your temporary emotional state.
So researchers are actually looking at things like user personality traits, or those classic principles of persuasion.
Yes, exactly. They're conducting empirical studies to see how user characteristics, like maybe the big 5 personality traits, influence which arguments land better. They also connect it to established principles, like those identified by the psychologist Robert Cialdini, things like authority, scarcity, social proof, reciprocity.
Okay, and how does that link to arguments?
Well, what's really interesting, and this is where it gets potentially problematic, is that some common patterns of argument called argumentation schemes, like appeal to authority or argument from popular opinion, can be linked directly to these persuasive principles.
Ah, I see. So an AI could potentially leverage that link. Like if it models that a user seems to respect authority, maybe it preferentially uses arguments that appeal to authority when trying to persuade them.
Exactly that. And while this could make the interaction feel more natural or effective for, say, positive goals like health coaching, the paper explicitly discusses the concern of manipulation. Leveraging these non-rational human features, whether it's personality, emotional state, cognitive biases, it opens the door to using these systems for subtle, highly tailored persuasion that might bypass critical thinking.
That's a really crucial point. The system might learn what makes you, specifically, tick, and then tailor its arguments just to exploit those tendencies, not necessarily to help you understand the issue better. The example they give about arguments for political resource management being more persuasive depending on the user's specific concerns really highlights this potential.
Hmm. Researchers are using techniques like user modeling, building a profile of the user based on their behavior or stated preferences, and also reinforcement learning. That's where the system learns over time which arguments were effective in past interactions, allowing it to optimize its persuasive strategies for specific users or user types. It's all about making the AI's arguments resonate with you.
Which, as you said, has a definite dual edge. Powerful for education or decision support, maybe, but really risky for manipulation if not handled carefully.
Precisely. And it's a key ethical challenge the field is actively grappling with as the technology advances.
Okay, so wrapping things up a bit, what are the big picture future trends and challenges this paper leaves us with? Where is the field heading?
Well, across the board, getting enough high-quality annotated data remains a huge challenge, especially for argument mining in diverse domains and languages. Annotation is expensive and time-consuming.
Still a bottleneck.
Definitely. For KRR, the big push seems to be making the models better at handling real, messy human arguments, including all those implicit parts, the incentives we mentioned, and the influence of context rather than just clean synthetic textbook examples.
Making them more robust to how people actually argue. And for HCI.
Yeah, for HCI, generating truly coherent domain-independent arguments is still really hard.
Yeah.
And properly evaluating how persuasive these systems actually are on humans in larger, more realistic studies is difficult, partly because there's a lack of public data sets showing how people genuinely respond to different arguments from AI systems.
Data again. And finally, going back to the LLMs, what's the paper's sort of concluding thought on their role in all this?
It really reinforces that main point. While LLMs are incredible language tools, they fundamentally lack explicit logical reasoning capabilities at their core. Computational argumentation, on the other hand, is all about modeling that reasoning process.
So rather than one replacing the other, they're complementary.
Highly complementary, yeah. The paper suggests the most exciting future direction is probably combining the language generation and understanding power of LLMs with the structured, logical reasoning capabilities developed over decades in computational argumentation.
To build AI systems that can genuinely understand and participate in reasoned debate, not just mimic it.
That seems to be the vision.
Okay, let's quickly recap this deep dive then. We've journeyed through how researchers are trying to build AI that can identify arguments in text, represent them computationally, evaluate their strength, and even try to argue back or persuade a human user.
Yeah, it's a massive undertaking, really inspired by trying to computationally model how humans navigate the complex world of debate and influence.
And you can see this work isn't just theoretical, right? It's laying the groundwork for tools that could help us make sense of overwhelming online discussions. Maybe support better human decision-making by analyzing pros and cons, and create AI assistants that can engage in more sophisticated, reasoned dialogue, not just follow simple commands.
And as these computational systems get better and better at understanding not just the logic, but also those subtle human-specific aspects of persuasion, how our personality, our values, maybe even our emotions influence which arguments we find convincing.
Right. Here's where it gets really interesting and maybe a bit unsettling.
How do we ensure that this incredibly powerful capability is used to foster understanding, critical thinking, and, robust discussion?
Rather than becoming the ultimate tool for personalized, perhaps even undetectable manipulation.
That seems like the critical question hanging over the entire field as it moves forward.
It's definitely something for all of us to be thinking about. Thanks for joining us for this deep dive.